Pray. Heavenly Father, and say thank you for the gift of this day. Thank you for the gift of this morning that you brought to us. Father God, as we're going to start our lesson, may you begin with us and end with us. Enable us to understand it. Pray all this in Jesus' name. Amen.
Amen. Thank you so much, Joan. Joan, can you go on and read for us the reflection item we want to start with?
Pardon?
Can you read for us what you are seeing on the screen?
Okay. On the screen, I'm seeing reflection. Imagine you have 10 hours this weekend and you want to split your time between studying for an important exam and helping a friend with a project. Studying improves your grade while helping your friend build your relationship. However, you can't spend more than 10 hours total, and you want to achieve the best balance between both activities. How would you decide how many hours to allocate each task to get the best outcome?
Okay, thank you so much, Joan. Anyone with an idea, kindly raise up your hand and then you can share with us what you think. Anyone with an idea? Anyone? Anyone? Okay. Now, the topic we are going to start today is a topic that will require us to be long thinkers, that is going to require us to be able to make decisions in whatever, in the different situations we are going to be coming up with. Many times we meet ourselves when we have limited resources, but what we want to do is a lot. So whenever you find yourself with limited resources, you have to come up with a choice or with a solution to what you have. So one of the things that this topic is going to do for us is going to help us to know how to make decisions based on what we have at hand. So here, when you look at this reflection, you are not saying that you have two things to choose on and you have limited time. Therefore, you need to make the right choice for you to go ahead. So that's what we are going to look at in this particular topic. So our topic today is under the theme patterns and algebra, and it is called linear programming. Those who have looked at the sample papers, at the past papers, you might have noticed that it is one of the common numbers or items that is always set. Whenever you look at item 2 for any math paper, if you don't find a number on linear programming, you'll find something related to maybe spontaneous equation. But linear programming is going to be something you will see oftentimes for almost all the items you are going to be doing. So this is a topic we are starting with. So, and it is always item number 2. It is always item number 2. Okay, let me ask you outright. Our topic, linear programming. Okay, let me hope everyone has finished. And our competence is that by the end of our our topic, you must be able to understand and use linear programming to be able to solve various problems. That is the competence. And for our lesson today, our major learning outcome is going to be that by the end of this lesson, you must be able to form linear inequalities based on based on real life situations. So our focus today is going to be how do we form those linear inequalities when we have scenarios. So that is what we are going to be doing for today. Okay, and that is going to be our major area of concentration. Now, I want you to look through the word puzzle and identify any words that you think are going to be key in this topic. So just look through and see whether you can identify some words. Feel free to write on my screen if you identify any word. Feel free to write on my screen if you are able to identify any word. Or if you identify any word, feel free to type it in the chat. Any word you can identify. So here I'm testing for your observation skills. Okay. Hunter is identifying function. Okay. Function. Shekaina has identified function. Okay. Okay. So it seems people are still observing, but allow me now to share the puzzle and then look at some of those words. They may not be so easy for you to see, but those are some of the words that we are going to be using for this particular topic. So those are some of the words you'll find in this topic. They are not so easy to see from the puzzle, but some people had identified region, function, yes, solution, constraints. So those are some of the words, and I'm going to ask you to write those words down, some of the keywords that during your research time, you look out for the meaning of those particular words. So we shall look at the feasible region. We are going to look at what we call objective function. Sometimes, depending on the book we are reading, they can call them linear function. We are going to look at what we call variables. We are going to look at what we call optimal or optimum solutions. We shall look at what we call the decision variables. Then we shall look at what we call maximization or minimization. So those are some of the keywords we are going to look at in this particular topic. Yes. So the first slide had linear programming as our topic. Okay. People are saying they have finished to put down the words. Okay. Yeah. read through, and then you can raise up your hand and then you share with us. We have a school that has prepared to take students on a tour and has 2 transport options to choose from. Which mode of transport would you recommend and why? So you can raise up the hand and then you share with us your thoughts. Okay, we are starting with yes, Amara.
Good morning, teacher.
Yes, good morning.
Teacher, my idea would be the one on the left.
Okay,
Because due to the fact,
let
yes,
me specify. One is a coaster, another one is a bus. The big one is the bus, then the other one is a coaster.
okay.
Mm.
I would say the one of the bus. The bus would be a better choice because first and foremost, this is a school and they want to carry a number of students. Because yes, the bus may take as much fuel, but also you're hitting two birds with one stone because you're going to be able to transport as many students as you can.
Mm.
That's why I would pick the bus.
Okay, thank you. Thank you. Yes, Desire.
At times, the number of students might be more and they may all not be able to fit in a bus, and it may need maybe more than 2 shifts, like
Mm.
for the whole number to be taken. Whereas
Mm.
when you compare a bus and a coaster may take a shorter distance to reach the
Mm.
destination, and it may
Mm.
take more turns, more routes, more shifts compared to what? To a bus. So at
Mm.
times, depending on a number, people may opt for a coaster because it may be faster.
Okay, very good. Jonah.
Good morning, sir.
Yes, good morning.
For me, I think I will recommend them to use a coaster because uh, it might be of less costs than a bus because
Mm.
they can be able to minimize expenses. Thank you.
Mm. Okay, thank you. Thank you. Now, from their submissions, they have brought out 2 words. Let me start with Jonah. Jonah has talked about minimizing the costs. Minimizing the costs. Then, someone talked about that as times you may find you want to take very many children, and he talked about maximizing. Then, another person talked about the transport costs. Another person talked about the distance. Yeah. Now, when you look at everything they have mentioned, you are not saying that there is something that requires us to make a decision. Now, whenever you are to meet these linear programming items, you need to look out for what is the decision variable. What is it that I must depend on to come up with a decision? Is it the bus? Is it the coaster? Now, the 2 things, the 2 options that have been presented to you are what we shall be calling the decision variables. We have started now. Now, when we talk about decision variables, those are like the things that when they change, when one of them changes, you'll have you'll take another option. That when one of them changes, there will be an effect that will be felt. Take an example. When you take on a bus, you may find that you may be spending more money and taking less children. Whereas when you take a coaster, you may find that you are using less money and all the children are taken, though they are taken in maybe in different, using like, you take them on using different, are they called loads, something like that. So Those are what you call decision variables. So whenever they talk about decision variables, you must look at those things in your item that are going to change the equation. That when one maybe changes, the other one also changes. When this one changes, and the other one also changes. But those decision variables are the ones that are going to help you either to minimize or maximize depending on the question. And whenever we talk about linear programming, we are looking at minimizing and maximizing. So here you want to ensure that all children go for the trip. However, much as they are going for the trip, you want to make sure that the costs are not so high, but you are working within the budget that you have come up with. Okay, I have another scenario here. Someone is going to raise up the hand and then they read for us. Okay, Desire.
Mr. Nicole is preparing for the new school term and wants to ensure her son Frank has everything he needs. She has a total of Ugandan shillings 100,000 to cover both snacks and pocket money for him. Each snack pack costs Ugandan shillings 10,000 and Mrs. Nicole wants to provide at most 6 snacks packs. However, Mrs. Nicole believes pocket money is more essential for Frank than snacks. She plans to allocate more money for pocket money than she spends on snacks. With this in mind, she aims to balance her spending while staying within her budget and ensuring Frank is well provided for. Can you help Mrs. Nicole decide how many snack packs to buy and how much pocket money to give Frank?
Okay, thank you. Now, those are our snacks. Some of you, when you're going back to school, you want to take some snacks. And one of the snacks that I always recommend is taking some peanuts, or what I think they call them peanuts. But also you may need some money with you, such that when the eats are done, you can have something to use to buy for yourselves. Now, the first task is here. So answer in the chat. Answer in the chat. Put those two things in the chat. Read through the scenario. I want you now to look at the first item. The first item is asking, what two things will determine how Mrs. Nicole will spend her money? According to Iraz, she has mentioned, Daniela. Okay. Okay, I'm seeing some answers are coming into the chat. Some answers are coming into the chat. Okay, very good. So people are saying that for her to spend, she'll depend on two things, the pocket money and the snacks. And I want to let you know the cost of the pocket and the snacks. Yes. So those are the two things that are going to determine how Mrs. Nicole will spend. Very good. And now I want to let you know that those two things you have mentioned, what we have called the snacks and the pocket money, are what you call our variables. So those are going to be our two variables that we are going to use. Very good. Thank you. The second question is there. What conditions is Mrs. Nicole working on? Put in the chat again. Put in the chat. One of the conditions Someone is saying she must be able to balance her budget. Okay. She's working on making sure the pocket money is higher. Very good. The money of snacks should not exceed the one of money. Okay, very good. Reduce or minimize costs. The cost, okay, very good. Now, looking through the chart, you are noticing that there are some conditions that she's working on. But like people have mentioned, they have said that when we read through together, Mrs. Nicole is paying for the new school term and wants to ensure that her son has everything she needs. Each snack costs and wants to provide at most. Now, this is one of the conditions she must work on, that the number of snacks she's going to give the boy should be at most 6 of them. However, they are saying that she's planning that the money for pocket money is more essential. So that one is also like a condition. She must ensure that it is fulfilled. But also she's aiming to balance her expenditure. So those are some of the conditions that are coming out from the question. Now, whenever you are going to be meeting these items, you are going to be looking out for those kind of conditions that are going to help you to either minimize or maximize. Now, that is the question. If Mrs. Nicole buys 4 snacks, how much pocket money will Frank receive? Hmm. Okay, I want to see. People are saying 60K, 60K. And someone, how are you getting 60K, you people? People are getting 60K. Okay, someone to share with us? Yes, Shekaina, you can share with us how you're getting 60K.
I haven't gotten 60K.
Okay, what have you gotten?
Wait. Oh, it's 60,000 because each snack pack costs 10,000 and Nico wants to buy at most 10. So I'm guessing we multiply 10,000 times 6 and then that's 60,000.
Okay, first now break for us the question. You have taken us marathon. First tell us, how much money is she going to spend on snacks? And how are you getting that money?
How much is she going to spend on snacks?
Yes.
Well, she has a total of 100,000 and she needs to spend both of it. It has to cover both the snacks and pocket money. So probably if we are we forming inequalities?
Not really. I want us to first tell you to first tell us that if she's to buy 4 snacks, how much is she going to spend on snacks?
To be honest, I don't know.
Okay, now
Haven't yet
read
worked
through
it
the
out.
question and first tell us, have you noticed the price for the snack? The snack pack?
One snack pack,
Yes, how much does it cost?
10,000.
So if you want 4, how much will that be?
That will be 4 times 10. That's 40,000.
So you shall say 4 times 10, and that is
40,000.
40,000. How much does she have in total?
She has 100,000.
So how are you going to get the remaining money after spending on snacks?
It's going to be 60,000.
How have you obtained 60,000?
100,000 minus 40,000.
100,000 minus 40,000. And you end up with
60.
60. Now, can you summarize for us?
I summarize. Okay. So basically, they gave us a total of how much she wants to spend total in everything, and they said that one packet of snacks is 10,000, but she wants to buy 4 snacks. So you multiply that and get the total amount of money you're going to spend on your snacks. And then to find out what the pocket money is going to be, because she has to spend both that money on snacks and pocket money, you're going to deduct 40,000 from the 100,000, where you get 60,000. So 60,000 will be her pocket money.
Okay. Thank you. We have another question there. What formula have you used to find the pocket money to be given to Frank? Yes, what formula? So if at all you have used some formula, you have reached somewhere, kindly feel free to raise up the hand and you share. What formula are we using in order for us to be able to get the answer? Or what have you done? Yes, I want us now to come up with a formula of how you have obtained the how you have obtained a 60,000. Okay. People are still thinking. Okay, yes, Desire.
I have less than the amount of what? Of pocket money to be X.
She has let the pocket money be X. Okay.
Then I went back to the scenario and saw that one packet of snack is 10,000. Meaning, if I'm to get 4 snacks, that would be 40,000. So to get the amount of pocket money, I say X plus 40,000 gives us 100,000.
Okay. Thank you. Okay. Thank you. That is okay. Then the last item. What is the end aim of Mrs. Nicole? What is the end aim of Mrs. Nicole? What do you think she's aiming at? You can put it in the chat what you think. What do you think the aim is? Okay, people are still thinking. People are still thinking. Okay, no worries. We are going to continue. We are going to discover. Yes. Yeah. Now, when you look at the pictures I've displayed some scenarios or some areas where we shall be applying the knowledge of linear programming. Some of you, you are going to be doing, sometimes you want to go somewhere and you keep asking yourself, can I use a car? Can I use a plane? Can I use a bicycle? So you want to ask when you are and sometimes you may find yourself you want to transport some things, but you want to make a decision on which kind of transport means to use. Some of you have been put on diet that you must take this, this, and this, and even conditions have been given to you. When you go to hotels, you find them always planning. So that planning, the main planning and the rest of that, always there is something there is mathematics behind it. And that mathematics behind the main planning, because if you are not good at planning, when it comes to business, you'll find out that you're going to be making a lot of losses. Imagine you preparing about 50 dishes and only 2 people turn up for the event. It means that you did not plan well. It means that you did not make the right decisions as you were planning. So you are looking at how can you plan. So when it comes to planning, we shall always need what we call linear programming. And that is our topic today. So when you find this topic, you are going to find it in the engineering field. Many of you want to be engineers. But whenever you go in for the construction activities, you always want to minimize the costs. So you'll find it that you're going to use it in engineering. Those who are going to go into manufacturing, those who want to go in for industrial chemistry, energy industry, transportation, agriculture. In case here you want to do the things of planting, those who are going into finance, marketing, and the rest of it. So it's going to be applied in all these fields. Whenever you go in those fields, you are going to find out that you are applying this kind of knowledge. So for this, I will ask you to read further about it. And then at the end of this topic, you will see the kind of relation it's going to be having with the different fields that we shall be meeting in real world. Okay, and now what is linear programming? Now, when we talk about linear programming, we are looking at how do we decide, how can we make a decision basing on the resources that we have. You know very well that we have limited resources, and if we don't utilize those limited resources very well, it means that we shall be wasting a lot. So linear programming is that topic that will help us make the right decision while minimizing the resources that we have within our reach. So the goal of linear programming is to ensure that the resources we have are being utilized effectively without wasting any. So it is going to be helping us to make those right decisions. Some of you are going into business. In those different businesses we are having, we must be able to make the right decisions if we are to get profits, or if we are to maximize profits in the different ventures we are going to go into. So you are looking at maximizing and minimizing. So those are the two things we are going to be talking about. So the question will either be maximizing or minimizing. Now, I want you to put for me in the chat, I have costs and I have profits. On the two, I want you to tell me which one do you maximize, which one do you want to maximize, and which one do you want to minimize. Put in the chat. I want you to say cost this, profit this. Yes, I want to see. Yes, I want you to know, don't just put for me profits, but I want you to, someone saying for profits, we are looking at maximizing. That is David Shekaina, and that is Ian. Yes, Shine, that is very good. And some people are saying for costs, we want to minimize. And those are the two things I want you to understand whenever you're approaching a linear programming question. You must be able to look at it, read it carefully, and ask yourself, am I looking at minimizing? Am I looking at maximizing? Those questions are going, that once you understand that thing, then it means that you will be able to use the right variables. It means that you'll be able to use the right inequalities. However, failure to understand whether you are going to minimize or maximize, it means that it will lead you to use wrong inequalities. And the moment you generate wrong inequalities, it means you have already failed the item. So you always have to read and ask yourself, am I going to maximize or am I going to minimize? Now, I want you to listen and you just put in the chat that that item requires maximization. That item requires minimization. The first statement I'm going to mention. So you tell me, does it require maximizing? Does it require minimizing? The school wants to transport 500 children. Listen to the question. The school wants to transport 500 children. Tell me, are you going to maximize? Is it a maximize? Minimizing. Now, people have started reasoning. Very good. So, looking. So, Ian, many, can someone raise up the hand? And then you throw some light on it. Yes, Samara, throw some light on that statement.
Yes,
But
teacher.
you can be writing.
Okay, yes, teacher. As you were saying that now they want to take 500 children, right? And first and foremost, with I would say Most especially, the money is the key thing because it's what's going to help pay the money to fuel the car and to pay the driver. So to me, the way I look at it, I would say that we'll have to minimize the cost because we want to ensure that we're able to transport the kids, but also we're able to reduce on the cost so that we can avoid like backlash from all of this or to avoid debts, basically.
Wow, perfect, perfect, good. Yeah, so we are right. Okay, we are looking at minimizing. Okay, now let us first write about linear programming. And whenever you find LOP, LOP will be standing for linear programming. Yes, but I want to let you know, Ali, that at this level, we do what you call basic programming. Yes, we do basic programming. Then when you advance, you can do what you call intermediate. But if you want to advance further, that's when you are going to meet advanced. Some of you, many of those problems we have, you'll find that they can be solved with minimizing. When you come to schools that are making losses, it is because they don't know how to apply linear programming. If you ever find at your school, when they are throwing food, when children are throwing food in those bins and the rest of that, one of the things the school has not yet invested in is a linear program, someone who can program for them. Because if you have a programmer in your school or in your business, it means that you cannot have any food wasted. In fact, everything that they are going to prepare, you'll find that it is used up to the dot. But also, if you find in your school whereby always food is not enough, you find that if children are missing food day in, day out, it means that those people are poor at planning. They don't know how to apply programming. Otherwise, if you have the number of children, you can plan better. So this topic is going to make you good planners, even when it comes to the different fields. If you ever find yourself that you are traveling somewhere, you are traveling somewhere and you find that the money you traveled with is not enough, then it means that you also don't know how to plan and your linear programming skills are poor. It means that one, you didn't choose the right choice of the transport means to use when you are going away from home, because the money you have must decide for you which transport means to use. Are you going to use a border, or you can use a car, or you can use? So this topic is going to be related to planning and how we can make the right choices in whatever thing we are going to be doing. Now, what are the key components in linear programming? Number one is what we call the decision variables. When we talk about a variable, we are looking at those things that change, things that vary. From the word variable, we are getting the word varying. Varying means like changing. So always look at your question and ask yourself, what things are varying? So take an example. When we are looking at the question of the coaster and the bus, it means the bus and the coaster are going to be the variables we are going to let, because those are the two things that are going to be changing in our equation. When we are looking at pocket money, we looked at pocket money and snacks. These are the ones that are going to make you make that decision. Pocket money or snack, pocket money or snack. So always look at the question and ask what things are changing, what things are going to be varying. Then when we talk about constraints, constraints are going to be those linear inequalities that you are going to be forming. Those are what we call the constraints. Then we have the data. The data, you look at those figures that have been given to you. Then the last one is called the objective function. Objective function is that decision function that you are going to use to make a conclusion. Remember at the end, like when I asked you for the other particular one, where I was asking you to, which equation have you used in order for you to come up with the pocket money the parent is going to give the child. Now, that function is what we call the objective function. Is the one that decides that for this person, this is the best thing she can do. For this person, this is the best thing to do. So that's what we call the objective function. Okay, members, let me know whether we are on the same page and you are done writing. Are we on the same page? Okay, yeah. So it seems we are on the same page and no one is left. Okay, very good. That is very interesting. Now we are going to start. We are going to start. Now we have started what we call the real linear programming. So anything now we have started, if you have not been paying attention here, now pay attention, because this is what is going to be the key in everything we are going to do. Now, allow me to first introduce to you the simple inequality phrases that we are going to be meeting. Now, when you meet a linear programming item, you are going to be looking out for those mathematical words. And some of the words they use, whenever you find these words, it means that you need to know which inequality sign to use. When you find a word less than, fewer than, lower than, smaller than, shorter than, below, it means that for that one, you are going to use a less than sign. When you find words like more than, exceeds, beyond, larger than, longer than, above, it means that it requires to use a greater than. But when you find the words at least, greater than or equal, minimum, not less than, not fewer than, not below, not smaller than, then it means that the inequality is greater than or equal to. Then similarly, when it comes to less than or equal to, those are the words. So those words are going to be very key when we are forming these constraints. So let me now start using the word constraints. So when I talk about constraints, what should come into your mind are those linear inequalities we are going to be forming. So let us first write. So make sure, once you understand, these are some of the few words, but there are other many words. Okay. So, but do not forget, in this topic, there is a lot of writing. Yeah, there is a lot. And going forward, sometimes I will just be telling you to just take a screenshot, because some items are really very long. Yes, and if we write everything, we may not be able to complete. So there's a lot of writing in this topic. So in case you want to break down the word constraint, constraints means like limitations on variables that are modeled. So we are going to be forming models, and those people want to be very good at data analysis. People want to be good at programming. Yeah, these are some of the mathematical topics you are going to find yourself using. So constraints are like the boundaries, limitation. Okay. When you finish, you let me know. Anya, are we on the same page?
Yes, sure.
Okay. What of Angel?
Yes, teacher.
Okay. Okay. Julia said she has finished. Okay. Caroline, are the words clear?
Yes, sir.
Okay. What of Emma? Okay. Yes, Iraz.
Good morning, teacher.
Yes, good morning.
So I was asking because at times I've been finding some scenarios, and for example, they say the bus is to take 20 pupils. I would like to clarify me on which inequality symbol can I use the
Okay. Okay. Yeah, don't worry. Just keep on. We are going to do all those scenarios that
okay.
involves, and I will tell you. And now for that particular one, you need to know, is it minimizing? Is it maximizing to make a decision on the inequality sign to use?
Yes.
But I'm going to talk about it. Just keep on. I have about 8 to 10 scenarios we are going to do today.
Okay.
Unless time catches us. Okay, it seems people have finished. Okay, good. Now we are going to start. Now, what are the steps of approaching the linear programming item? So I've abbreviated this as linear programming item. Now, the first thing, I've told this topic we are going to write a lot, but don't worry. So steps of approaching the linear programming item. Number one, you define the variables. When I talk about defining a variable, defining means that you let what you are going to use. In other words, say now, for example, the question where we had pocket money, you can say, let the pocket money be represented by X. Let the snacks be represented by Y. That's what you call defining the variables. I have told that variables means those things that you see changing in your question and what the question is aiming at achieving. So that's what you call defining the variables. So you must always let, they are not going to tell you that let, no, it must come from within you. Then number two, you must form the inequalities satisfying the conditions given, including the non-negativity constraints. When we talk about non-negativity, non-negativity in terms of students, those are students that always think positively. You'll never find them thinking negatively. In other words, in real life, that we like these questions we are going to be dealing with, you cannot have a negative. Take an example, saying you have a negative car, you have a negative road, you have a negative things. No. So here, expect that always, always your answers are going to be positive. In other words, say like you have said your pocket money is X. So we can't say that our X is less than 0. This is impossible. You can't have, your parent can't give you negative pocket money. So that one, it means that she has not given you. So always, we are going to find that our answers are going to be always, your variables you have rated are going to be greater than or equal to 0, or Y greater than or equal to 0. And these are what we call the non-negative inequalities. So non-negative, it means X is greater or equal to 0 and Y is greater than or equal to 0. So whenever you hear non-negativity constraints, non-negative inequalities, it means that X is greater or equal to 0 and Y is greater than or equal to 0. So this one shows you that for whatever thing you are letting, it cannot be a negative. So it must always be a 0. And at a later time, I will tell you that for whatever number you are dealing with, make sure you include the non-negativity to show you that you cannot have or you cannot obtain the answer of X and Y as negative. Okay. Then number 3, formulate the objective function. This is the decision function. So always we must have what we call the objective or what we call the linear function. And that function always is written in terms of the variables you have let. So in case it's X and Y, you write it in a form. And once you fill in those different values in your equation, then you must be able to come up with a conclusion. So summarize those three things. So I'm going to ask Ian, yes, let's concentrate. Hmm. 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 Yes, and I'm briefly going through the chat, and I'm worried that some people still have challenges with the mindsets. Yeah. And some are short-sighted. Yes, okay. Okay, I think people are finished. Now let us start on our activity. So we are going to look at forming linear inequalities based on real life situations. I want to let you know that in this topic, we are dealing with only word problems. Word problems. Okay, and this is going to be my first activity. Now, my first activity is telling me that Mr. Opio is a farmer who grows both maize and beans. I'm going to ask in the chat to tell me, first, when you look at this question, what two things are going to be varying? What two things are going to be changing? What two things are going to decide the variables we are going to use? Put them in the chat. Put them in the chat. I want to see whether people are following. Now we are looking for decision variables. Aha. Yes, yes, yes. You people, you are very brilliant. Yes, yes. Aha. Now, those two things you have mentioned is what we are going to be letting to be our X and Y. And I want to let you know that it's not a must, but always I advise when the first thing that has been mentioned, let it be your X. The second thing that has been mentioned, let it be your Y. So here, what we are going to do, we are going to just, we are going to come and say that the first, I think, is define the variables you are going to use. So I'm going to say that let the number of maize fields be X. Then let the number of bean fields fields be Y. That is the first thing. And this is where you're going to earn your first mark or score for formulation. So please make sure you first write those opening statements. That's what defines what you are going to do. Then number two, now we are going to formulate our model. Okay, now they're telling that he has limited resources and must adhere to certain planting restrictions for optimal crop rotation and yield. The following conditions govern how many fields of maize and beans he can plant. Now, we are going to write inequalities for per item. He must, number one, he must plant at least 2 fields of maize. I want you to look in that question. Which mathematical statement have you identified? He must plant at least 2 fields of maize to meet market demands. Are you identifying any mathematical statement? Which word is that brings out the mathematics of the inequality that you are going to use? Very good, Isabella. Very good. At least greater than or equal to. Very good. Now I'm going to come here and I underline that word for you. That this word at least is what we are going to, and they're telling at least 2. So meaning that since we have said that our maize is X, and here in the question, I think at least 2 fields. So I'll come and I say, my inequality is going to be X greater than or equal to 2. Because they have said plant at least 2 fields of maize. So that is what we are going to write. Hope that statement is okay. Hope that statement is very okay. Members, is that fine? Is that fine? Let me know through the chat whether that statement is okay. Audrey Mwini, are we together?
Yes, teacher.
Okay. Okay, Emma is saying yes. Okay, that is the first statement. We are continuing. People are saying we are together. Yes, it is very okay. Very good. We go to number 2. Number 2, they are telling us that he must plant at least 2 fields of maize to ensure a balanced crop yield. Underline your mathematical word, at least 2. So I'll also count. But remember, for beans, we have used y. So I'll say y is greater than or equal to 2. We go to number 3. The total number of fields used for maize and beans must not exceed 10 fields. Kindly, first write for me that inequality in the chat. First write for me what you think we are going to do. Try it. First write for me what you think you are going to write. Read the question again. The total number of fields used for maize and beans must not exceed 10 fields in total, as it has limited land and space. Less or equal to at less than or equal to, less than or equal to, less than or equal to. Okay, less or equal. Very good. That is true. Yes, because you have to go back. Here the mathematical word is must not exceed. Now, even when you go back, and can I even let you know, the moment you see the word not, that negativity, your inequality must always have equal. That equal. The moment you see the word not, your inequality will have that word. So when you come back here, let me take you back here. You can even look here and say, where is not exceed? Where was it mentioned that it is here? Are you seeing? So that's why I gave you some words to guide you. So the moment you see not, then please let you know that you are going to have an equal on it. So that means when we have the number of maize plus the number of beans, it must not go beyond 10. In other words, 10 is like the maximum number of 10 is the highest figure. So we shouldn't go beyond that. It is the highest. Okay. Then we go to number 4. He must ensure that no more than 6 fields are planted with maize to avoid overuse of soil for that crop. Which inequality are we going to use? No more than 6 fields. Which inequality are we going to use? No more than 6. Which inequality are we using, members? Put in the chat. I've already told you less than or equal. Thank you, Kayongo. Isabella, not really. Less than or equal. I've told you the moment you see the word no, this negating word no, not, it means that you are going to have an equal on your statement. Then for the next thing you have to understand, when they say not more than, it means that when I say that not more than 90, I expect you to have at least 90 and below. That is the meaning. No more than, not more than. So I'm going to come, and since this one they said maize, then I'll come and I say our maize will be y less than or equal to 6. Members, may I know through the chat, are we still on the same page? Are we on the same page? Make sure we don't leave you. Are we on the same page? Okay. Okay. Maize is X. Okay, good. So this is X because they said maize. So this is X. Okay. It seems we are on the same page. It seems we are. Okay, we are on the same page. Amara, you are saying you are not on the same page. Was it Amara that I saw? Yes, Amara.
Teacher. it's kind of confusing a bit because due to the fact that now we are dealing with word problem. Word problems always disturb me a bit. So I just wanted to ask something here. So when they say, let me say number 3, when they're talking about the total number of fields used for maize and beans must not exceed 10. So you're telling me that from that word must not, from the word not is like telling us it should say equal to, then the must not exceed is meaning less than or equal to, right?
Yes, it shouldn't go beyond.
So basically, if now, okay, let me say like if we changed it, maybe if it said that the total number of fields used for maize and beans must exceed 10 fields in total. So that means, would it say it's greater than or equal to?
Now, when they say must exceed, that
Yes.
is now, it must go beyond that.
Okay.
So that one is just greater.
Okay, then my last question is number 4. Number 4 was saying that he must ensure that no more than 6 fields are planted with maize to avoid overuse of soil for that crop. So they have said no more. So no more is still referring to it should be less than or equal to.
Not more than that. So when I say not more than 5, so when I say call for me not more than 5 children in class, how many children would you call?
I'll call 5 or less than 5.
Yes. So that is why we are using less than or equal to.
Okay, teacher, thank you.
Okay. Then we go to the last one, number 5. He wants to maximize the overall crop yield from maize and beans, considering the market value of each crop. The value per field of maize is this, while the value per field of beans is this. Now, this is where, now this number 5 is the one that I want us to use in order for us to find how much this person is going to gain when he plants a specific number of fields of beans and why. I want you to generate for me an equation. Just imagine, we are going to generate an equation that relates to the number of fields and the number of beans. And that equation is what we call the objective function, like that decision function that we are going to use to know that if I plant 5 maize fields and 2 maize and 3 bean fields, it means I'll be getting this amount of money. If I plant this and this, I'll be getting this amount of money. So that one, allow me to say that we can use that function x, y, and for us to get the number of fields of the amount we shall obtain from maize fields, I will say 200,000 times x plus 150,000 y. Now this function here I am forming, at times we can use f, at times if it is cost you can use cxy, depending on the letter you want to use. So what happens that when I put here 1, x represents the number of maize fields, y represents the number of bean fields. So this function I've written here, it is the function that is going to help me to know how much do I earn when I plant a specific number of fields of beans and what? And beans. Then it is from that equation that I can come to know whether I'm making profits or I'm making losses, depending on how much money I have invested in my planting. Members, may I know whether we are on the same line? Are we on the same? Some are saying no. Okay. Yeah. Okay. Allow me to use an example. Now, like I've told you, in case I want to find out, take an example. Mr. Pio has planted 2 maize. This one is just an example. Just imagine he has planted 2 maize fields, and maybe he has planted 8 bean fields. This is just my example. Now, in case I want to find out how much money is going to get, because they are saying that every field of maize is going to get 200,000. Every field of beans is expected to get 150,000. So in order for me to find how much is going to spend, I'll come and say maize is 200,000. And how much fields has he planted? He has planted 2. Then plus, I go to beans. How much is each field? Is 150,000. Then times, how many fields has he planted? Is 8. Now this 2 is what represents the field of maize, and we have represented it with X. This 8 represents the fields of Y, which is Y. So here, the total amount you get is what we are calling the function, is what we call the objective function. It's the one that gives us the total value for what we have planted. So in case we replace where there is 2 with X, that's how we are getting the 200,000 X. Plus, when we represent the 8, we are getting the 150,000 Y. So this one is what gives you like the total value. So that is the function that gives you, that's the one that decides how much you are going to earn from the fields you have planted. Hope now we're on the same page. Hope now we're on the same page. Okay, yeah, okay, we are now on the same page. Yes, members, can we continue now to another activity? Isabel is saying yes. Yeah, yes, yes. Okay. So now we are going to the next activity. This is the second activity. Now, our second activity is telling us that a local restaurant is planning its menu for the week. They offer 2 types of dishes, vegetarian and non-vegetarian. This restaurant wants to optimize its menu offerings while adhering to certain budget and nutritional requirements. The following restrictions govern the planning. Now, please, this lesson, we are just formulating inequalities. We are not solving. Solving will be a lesson on its own. That one I'll create, we shall have a lesson on its own, how to solve. So today I want you to just learn how to generate those inequalities. It's the only thing we are doing. We are not solving any question. The whole lesson is just to learn how we can generate the inequalities. Oh, people are saying I need to zoom. Okay. I need to zoom. Okay, 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 okay. I don't know whether it is a bit clear now. Is it a bit clear? Is it clear? Not yet. Okay. Okay, it is a bit clear. Okay. Now, our second activity. Now, this is good. Okay, I think what I'm going to do. Okay, I'm going to zoom, don't worry. So when you look at our item, you are noticing that here we have 2 dishes. We have a vegetarian and we have a non-vegetarian dish. And we want here, what are we interested in? We are interested in finding out those inequalities. So the first thing I want you always to do is that first underline what 2 variables are changing. Dear members, let me know. What 2 variables are changing? What are we going to let? And I want you now in the chat to let me know what is your X and what's going to be your Y. Yes. Vegetarian is X. And non-vegetarian, Y. Thank you. Thank you. So here I'm going to say, let X equals to the number of vegetarian dishes to offer. Then I will say let y equal to the number of non-vegetarian dishes to offer. Very good. Now I go to the first statement, this one. They're telling us the restaurant must offer at least 5 vegetarian dishes to cater for the vegetarian customers. Now you need to identify which inequality suits that. Mujuni, which inequality suits that word, at least 5?
Greater than or equal to.
Tell me now what are we going to write now?
So since x is our vegetarian, we're going to say x is greater than or equal to 5.
Very good. X is greater than or equal to 5. Very good. We continue. Number 2, the total number of dishes, vegetarian and non-vegetarian, should not, I've told you, the moment you meet the word not, exceed 15 dishes in total. Who wants to give us that inequality? Amala, you tell us now to check whether you understood the concept.
Okay. So the second part is saying the total number of dishes in brackets vegetarian and non-vegetarian should not exceed 15 dishes in total. So teacher, I think it's going to be less than or equal to.
Tell us what, right?
Okay, so you write x plus y less than or equal to 15.
Okay, good. Then we continue. Yes, members, this is very good. I'm seeing the answers in the chat. Favor, that is good. Rima, Patricia, Ian, Daniela M. Yeah, the answers are very correct. Okay, we continue. The budget for purchasing ingredients for the dishes is 2 million. Now, the person who was asking me about the bus things and the rest, understand from this point, the budget for purchasing ingredients for the dishes is 2 million. Now, I want through the chat to tell me, which inequality do you think we are going to use? They have told that this person has in her budget 2 million. Which inequality do you think we are going to use? Chisache Maka is saying greater than or equal. Ilas is saying less or equal, less than or equal, less than or equal. Let me first hear from Chisache. Chisache, have your hand up. Chisache, don't run away, come here. Yes, Chisache, give us a reason.
I think you use greater than or equal to because when you're budgeting, it's like you're planning. You plan for more than because you cannot be sure.
Okay, now Chisache, can I ask? Chisache, come back. Don't run. Chisache.
Yes.
Now, your mom has given you 2 million. Okay, let me say 50,000 for pocket money, Chisache. Yes?
Yes. Yes.
And when you say greater than or equal to 50,000, how much can you have?
I can have 50,000 or more.
Or more, not so? Like 60, 70, and the rest. Chisachi, where are you going to get the 60 if you have 50,000 that your mom has given you? Where would you get that extra 10?
Oh, I now understand.
Okay. Hope now it is clear. Yes. Now, members, when they tell you that the budget is 12 million, that's what you have. Meaning that you can't go. Yes, Jonah.
I'm just answering that question.
Okay.
They told us that the budget for purchasing ingredients for the dishes is 2 million. So I think we are going to use less than or equal because it is the available money. It can't exceed that. So it
Okay.
will be less than or equal.
All right. Perfect. Members, hope you have got that. Now, members, we are combining these two questions, eh? And we are going to form our inequality. Each vegetarian dish costs 100,000 to prepare, while each non-vegetarian dish costs 150,000. Members, can we first generate an inequality for combine those two to find out how much shall we have to spend if we are to work within our budget? Remember, when you say x plus y, remember x didn't represent costs. X did not represent any price. It was just representing vegetarian and a dish. So you cannot tell me vegetarian plus dish should be less than or equal to 2 million. So remember, you must, now when they bring in money, kind of also bring in the money concept. Hope Rima, we are together. Now we are combining that. I've told you how much it costs to prepare a vegetarian dish and how much it costs to prepare the what? The non-vegetarian. Daniela M, that is very good. If Daniela, you could only unmute and oh, okay, Daniela M.
Yes, teach.
Tell us, Daniela M. What you have written.
So, given that X was representing the vegetarian meals and Y for the non-vegetarian, and so I saw it as X representing the number, but not the price. So I just did it as X times the 100,000 plus the 150 times the Y for the non-vegetarian, which is less than or equal to the 2M.
Okay, very good, very good. So members, please take note of that. This one is the cost you are going to spend on preparing a vegetarian dish. This one is the cost you are going to spend on preparing a non-vegetarian dish. But the total amount that you are going to spend on preparing a vegetarian and a non-vegetarian dish shouldn't go beyond the 2 million. Members, hope that is very clear. Now, when we reach solving, I'll let you know that we go on and reduce our inequalities. But I'm interested in us learning how to formulate. Reducing will come in later. Then we are going to continue. The restaurant wants to maximize the nutritional value of the menu. Each vegetarian dish provides 8 nutrition units, and each non-vegetarian unit provides 10 nutrition units. Members, this last item is the one that wants us to formulate what we call our objective function. Because we are interested in finding out that when you take a vegetarian dish, what are the nutrition value for that particular menu? So for that one, we shall just say that our function written in terms of f, x, and y will be 8 for the vegetarian, then the 10 for non-vegetarian. And then you end there for now. Members, are we on the same line? Sache, Shine, Nanyanzi, all of your answers were correct. Daniela Joy. Members, are we on the same page? Okay, I'm saying yes, yes. Okay. Okay. Okay, someone said sure. Okay. Now allow me to continue, but I'm limited with my screen here. I'm limited. Yes, Olive.
Excuse me, sir. I'm still confused about this function. That f into bracket x comma y. I'm still confused there. Maybe you can help me.
Okay, Mugisa, have you studied functions?
Yes.
Do you know how to substitute in functions?
Yes, I know.
Yes. Now, this is where I want you now to relate. That where there is x, like take an example here. Take an example, you have been given, you may find that the dishes you have prepared are 5 for vegetarian, and you have prepared maybe 2 for non-vegetarian. So to find out the total nutrition value, you'll just come and say each dish of each vegetarian dish, they are telling you it has 8 units. So that means to get the total number of units, you say 8 times the 5 dishes you have, then you get the total. Then for non, you say each dish has 10 units, then times how many dishes you have prepared, which is 2. Now, when they ask for the total nutritional value for the menus that you have prepared, that function that leads you to get that is what we are writing. Instead of doing it step by step. I don't know that you're getting the idea.
I have got you, sir.
Okay.
Thank you.
Okay. 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 So today we shall end at 8. Sorry, at 7. At 7. Okay. Okay, allow me to clear, but I'm seeing a hand from Jonah. I know some people may be still writing. Yes, Jonah?
Teacher, I just have a question.
Mm.
I'm just assuming if they say that maybe the vegetarian dishes should be more than the non-vegetarian by 4. How are we going to write that?
Now we are going to look at a question of that nature. How you will say y plus 4.
Okay.
We are going to look. We have just started. Okay. I don't know. Someone made a suggestion in the chat, but allow me to key in my screen, and then I pray that I think this one is a bit clear. Okay. Now we have another item. They are telling us that a furniture company has 120,000 to invest in making tables and chairs. Members, first let me know through the chat what is going to be your X and what is going to be your Y. What's going to be your X and what's going to be your Y? Yeah, all the answers are correct. All the answers in the chat are correct. So that is always the first thing we do. Define what you're going to use. So we are going to say, let X represent the number of tables. Let Y represent the number of chairs. That is always the first thing. Now, we have started linear programming. The first one, I was summarizing for you. Now, it's not for summary. You have now to summarize for yourself. That's what we are going to. So the first one, I was summarizing. Now, for this particular one, you have to summarize for yourself. Now, the best way to summarize these items is drawing a simple table. Now, I'm going to draw a simple table, and in this table, I'm going to first label what things do I have, or what, after defining the two variables, that in this table, I'll have my tables, I have my chairs. Now they're telling us that I want you to be very observant what I'm doing, because when you make a summary, then it becomes very easy for you to come up with the inequalities. Now they're telling that a furniture company has 120,000 to invest in making tables and chairs. It costs 20,000 to make each table and 12,000 to make each chair. Now I'm going to come here and I say, the first thing, I'm going to look at the costs. Then I look at the table is 20,000. I will put here 20,000. For the chair is 12,000. And down here, I'll come here and I say, how much total does the company have? That this company has 120,000. Members, hope that summary is okay. Is that summary fine? The first summary I'm making? Let me know, let me know, let me know. Is that summary fine for the first part? Okay, very good. Now, after that, I continue with my question. The company has a storage space of at least 8 items altogether. Now, I'm going to come here and I say storage space available. Now, when they have told us that the company has a storage space of at least 8 items altogether, meaning that when you combine the tables the company is manufacturing and the chairs the company is manufacturing, you must get a total of 8. So here storage space, I'm going to put 8. But since the table, assuming I have one table and one chair, it means that when I add what I have for my table and what I have for my chair, I must get an 8. Then I continue. Each table yields a profit of 80,000. This is the table, it yields 80,000. Then each chair yields a profit of 45,000. So here I will say 45,000. Now, after that, now this profit is what we are going to be calling now. This is what we call profit. And remember, we said that under profits, we always maximize. And this profit maximization is what forms what you call your objective function. Hope that step is very fine. Now, after that, we are going to form our equations. I go back. I want us now, we are going back. After summarizing your table, you are going to notice that the two things that are varying is the table and then the chair. So the first equation we are going to write is going to be about the costs. Here, it's going to be about the costs here. Now, what are you going to do? I want you to look at, they are telling you that a furniture company has 120,000. What does that mean, members? When, which inequality are we going to use? Let me know through the chat. If has 120,000, which inequality are we using? Less or equal? One. Less or equal? Less than or equal. Very good. Now, Patricia, when it comes to inequalities, you will never use an equal sign unless you're writing an objective function. All the inequalities we shall use will be either greater than, less than or equal, or greater than or equal. You cannot use an equal sign as an independent thing. Okay, very good. Now I'm going to write my first inequality. So my first inequality is going to be of cost, because we have said that when they tell that that's what it has, you cannot add on anything. That is the pocket money your parent has given you. So you cannot go on and get more pocket money from her. That's what she has given you. So when they tell us has that, so I'm going to write the costs. Then I will say, I write it vertically. I will say 20,000 X plus 12,000 Y must be less than or equal to 120,000. But like I've said, at a later time, we shall be reducing them. But now I want you to just learn how to generate. Okay. Okay. So that is one. Hope members are getting it. Then we go to the next one. It's going to be storage space. The company has a storage space of at least 8 items altogether. Members, can you first write for me that equation in the chat? Hey, first write it in the chat and we see. The company has a storage of at least 8 items altogether. I'm waiting for the answer. I want you to pick the word. Thank you, Mark. At least is the mathematical word. At least 8 or more. Very good. So I'm going to come here under storage. Under storage, I'm going to just put here, this is X, and some of you are not noticing. Here, I just need to put X, Y. Here, I just need to put X and Y. Since tables are X, this is Y. So I'm going to come here and I say now storage space. For storage space, then I'll come and say this is X plus Y must be greater or equal to 8 items. Yes. So here I'm ignoring the 1. I'm ignoring the 1 because it is just a coefficient. So you can ignore it. There's no need. Then we go to, now those are the 2 equations. Then the last one is each table uses the profit of this and this. So now we are going to form an equation for obtaining the profits. So I'm going to say, let the profit function be represented by f. So I'm going to say, here I can say objective function. So I will say my profit xy will equal to my profit, which is 80,000 x plus 40,000 y. And now this one is the one that will let us know how much profits have you obtained from your company. Take an example. In case someone goes on and in case he makes maybe two tables and maybe 3 chairs. In order for you to know how much profit this person has yielded, you will just come here, where there is X, you put 2, and where there is Y, you put 3. Then you get how much profit this person will obtain from the business. Is that fine, members? Are we on the same page? Are we on the same page? No, favor. 80 and 45 is looking at the profits you are making from your business. The 120,000 is the cost of making. So you cannot tell me that the profit you are making should be less than how much you have invested. I don't know whether favor you are getting it. Favor, hope we are on the same page. Okay, yes. So 120,000 is the cost of making, is what you have and you want to make. So your aim should be that the amount you get from your business is more than 120,000. Otherwise, if you do not, it means you'll be making a loss. So your profits always, now this is the profit function. So those are the 3 equations, members, we shall write. Okay. Yeah, may you let me know whether we are good to continue? Say continue, if to another item. Continue, people saying continue. Okay, we are good to continue. But let me first support, yes, Samsung. Samsung, unmute.
Teacher, good morning.
Good morning.
Yes, I'm question going to run.
2? Oh. I've not gotten your question. Oh, sorry, Samsung, I didn't pick your question. Where? Okay, we can go to another item. Okay, can you first write it? First write it in your book. And then I want you to first also give it a try. Yeah, I'm going to give you 3 minutes. First give it a try, and then we start from there. Hey, hope we are coming up with something. Yes, I want you to first do it. Where did this 2 and 3 come from? There was 2 in that question. Please, here we are not dealing with spontaneous equations. Here, these are inequalities. These are inequalities. There is nothing like solving spontaneous equations. So never think about spontaneous equations here. These are inequalities. So those who have just come in, it means that you came in when we have finished dealing with some words. Daniela Joy, how far?
I'm still working on it.
Okay. Can you first let us know what has been your X and what is your Y? Yes, Joy? What is your X and what is your Y? Okay. That is very important as you approach. So Favor, what is your X and what is your Y?
My X is the number of buses with 50 seats, and then my Y is the number of buses with 40 seats.
Okay. So X is your bus and Y is?
They're
Okay.
all buses, but the other has 50 seats and the other has 40 seats.
So 46 is the small bus. So it is your Y.
Mm.
Then
And then that one has 50 seats.
this one has 56. Okay. Very good.
50 seats,
50.
not 56.
Okay, 50. All right. Okay, that is good. So
So
we see.
even this other is 40, not 46.
Okay, this is 40.
Yeah.
All right. Okay. Now, the next thing we do after letting, we shall always have our table. Allow me to call this one a large bus and this one to be a small bus. So this one, I'll call it the large and the other one, I will call it the small. But please, large, I'm calling the bus with 50, then the small, the bus with 40. Then I'm going to first summarize. When you look at a question, they're telling us that they are preparing for 400 students. The company who is providing the class has 10 buses of 50 seats each. Now I'm going to look at the seating capacity of the buses. So when you look at the seating capacity of the bus, you are noticing that the large bus can carry 50. The small bus can carry 40. But the total number of students we want to transport, the total, is 400. Then I continue. I look at the number of the 10 buses. Okay, then we can look at, we have another one. But only 9 drivers are available. Then I'm going to look at the drivers that are available. So the large bus, let me here, I will just put 1 and 1 because each is taken on by 1 driver. And the total number is 9 drivers. So I mean that when I add the number of drivers of the large plus the number of the small, I must be able to get the 9. The rental cost for a large bus, then I say rent. This one is 800,000. Then this one is going to be 600,000. How many of each type should be used for the trip for the least possible cost? Now, I want you to first let me know, for the seating capacity, which inequality are we using? Yes, for that one, which inequality are we using? Let me know through the chat. So the first one, greater or equal to, less than or equal to. Yes, Iraz.
Yes, teacher. I'm saying that for that we shall use less or equal to, because when by the time they say a bus takes 50 people, it means it must be 50 or less.
And how many children do we want to transport?
And we want to transport 400.
400. So do you feel that when we say less than 400, what does it mean?
That means that we need to transport 400 children and less and below.
And less, not so?
Yes.
Would you have achieved your objective of taking all the 400 children for the trip?
I'm not sure then
Why? What is it that you are not sure of?
About
Okay.
why you are asking me,
Okay, just imagine we have senior 4, which has 400 children. And in this class, you want to take the 400 children for that trip, not so? So when you say less than or equal to 400, it means that you can take children that are less than 400 for that trip, not so?
Yes.
Now, when you look at your objective of taking all the 400 children, not so? Do you think that when you use less than or equal to, you will achieve your objective or not?
I think you will achieve it.
Now, if you take 300, have you achieved your objective?
If you take 300.
Because you have said less than or equal to 400. Will you have you achieved the objective?
Yes.
Yes.
Of taking 400 or less.
What about the 100 that are missing? Aren't there students also who want to study?
They are also students. So
What about if I take none of them? Because less than or equal means 0. What about when I take none of them? Have I achieved my objective of taking them for a trip?
no, then there it means you have not achieved that objective.
So which inequality do you think now we need to use?
So it is greater or equal to 400 students.
Yes. It is greater than or equal to. Members, let me know through the chat whether we have understood that. Yeah, people who have been saying less than or equal to. I don't know whether you have understood and you have been following. Okay, let me ask Joan, Unmute, and Mugisa, because that statement is very critical. Yes, Joan.
Sir, I was why you've not indicated the number of buses, because you've only indicated the seating capacity.
Oh, the seating capacity. No, you can, now, when you look at, I can include it, there's no number of buses available. Now, number of buses, here we have 10 buses, large buses, and 8. It is very okay, don't worry.
Okay, excuse me, sir.
Yes.
What I'm thinking, or what I'm asking, can we form inequalities with equal sign?
No. That is now ceases to be an inequality.
Because according to this question, I'm seeing that a school is preparing a trip for 400 students. So I'm not seeing any kind of at least, at most, more than, less
Have
than.
you been following my conversation with the gentleman?
Yes.
Yes. And that's what we have been explaining.
So now,
So
how can I know that this one needs less than, or how can I know that this one needs greater than?
that's what I've told you. You need to look at the objective of the question. You must understand the question. It's because these questions require a lot of understanding. Because here you are preparing for 400 students. Remember, when you are preparing for something, when you are preparing a party, one of the things you can never be sure of, one, is how many people are going to turn up. You may prepare for 400 or 200 people, and you get surprised that more than that will turn up. So if you say 400, what are you going to do for the rest that are going to turn up? So in inequalities, in linear programming, we don't use equal sign anywhere. Because you know very well that when I use greater than or equal to, here I have already catered for the equal sign, and I've already catered for in case the number goes beyond what I've planned for. I don't know you're getting it. Are you getting it? I don't know that Mugisa is still on. Mugisa, are you getting it?
On, sir, and I'm getting it.
Okay, yes. So that is what now I'm saying, that whenever you're making preparations, take an example, you're preparing yourself for the party, for this and this. Always it is a bad culture to prepare for a less than number. Always put something extra. That's why I was telling you that for a school where you find children are missing meals, it means that they are poor at planning. Yes, because when you are preparing something, always say, what if an extra number comes in? So you chip in something more. So in case you are preparing a party, you are saying that maybe for my birthday party, I'll invite 5. I know some of you have experienced this, whereby you say, I'll have 5 people. 5 people of my friends will turn up. And you get surprised that even people like me that you didn't call are turning up for the party, for the birthday party. So, meaning that if you have not planned for them, you are going to be suffering with the expenses. So here, when they say we are preparing for 400 students, always better you plan ahead than planning less than. So the inequality we are going to use for that particular one is going to be 50x plus 40y is greater than or equal to 400. Because you are looking at making sure that all the 400 children are going. You want to ensure that all of them are going. But as well, when they are going, remember your target as a person is that we say that when we are transporting members, are we maximizing? Are we minimizing? Let me know through the chat. Yeah, okay. Are we maximizing? Are we minimizing? I want to know through the chat. We are minimizing because we want to use as little cost as possible. So that's why it matches with greater than or equal to. Very good. So here we want to minimize. So this is going to be our first equation. I want you, if you summarize your data, you're going to find out things coming out. Now I go to the drivers. Now the number of drivers, they are telling us that means that when I get the number of drivers for the large buses, plus the number of drivers for the small buses, the number they're telling us that the number available is only 9. Members, let me know which inequality are we going to use? The number of drivers available are 9. So which inequality are we using? Okay. This question require understanding now. If the number we have is 9 drivers, which inequality are we using? Put it in the chat. Only 9 drivers. Very good, Patricia. Shine. Yes. Yes. Now I'm seeing people have started picking. So since there are only 9 available, the number can't increase beyond the 9. So 9 is the maximum. So that means I'll come and say the number of the drivers plus the y should be less than or equal to 9. So less than or equal to 9 means that x plus 9 can equal to 9, or they can be less than that number. But you know the maximum is 9. You can't go beyond that. Then the next one, I'm going to form the how much will I spend? Now that one is the cost. I want to know how much do I cost. That is the rent. So I will say cost xy is going to be 800,000 x plus 600,000 of y. Now, which other thing do you need to know? Another thing you need to know, dear members, is that one, they have given you, when it comes to objective function, it will always depend on the cost. But you can have more than 2 objective functions, because when you look at this question, how many buses of each type should be used for the trip, such that you use the least cost, meaning that here x is the number of trips, x is the y is the number of the trips. Now, meaning that when you take 2 trips and 3 trips, you know how much money you're going to spend and the rest of that. But now another thing I want you to let you know that sometimes when you look here, the number of buses available are 10, the small buses are 8. You may find that there is not anywhere where you're going to require to use that kind of inequality. So sometimes there are values we may have that we may not be able, that we are not going to use. Let me hope that one is clear. So you can just leave them like that. But still, sometimes these values can help us when we are generating, the objective function in order for us to make a conclusion. Yes, Samsung.
Yes, good morning.
Morning.
Actually, my question is where here on drivers, where you have put x plus y is greater or equal to 9. Where you have presented 1, 1, am I going to get 9 and divide for the buses, this many
No,
drivers?
here, that one, remember here you just put x, here you put y, not so? So 1 times
Yeah.
x is x, 1 times y is y. That's why you don't carry the ones.
Okay.
But here I've used less than, I have not used greater than.
Okay. Thank you.
All right. Okay. Now, members, like when it comes to linear inequalities, I want us now to start including what we call the non-negative inequalities. So non-negative, it means that we can't have negative buses, and we can't have negative small buses. So you'll find that these 2 inequalities are going to be applicable, but we shall be including them when it comes to solving. Okay, members, are we still together? Are we still together? Are we? Okay, paper saying, yeah, we are. Yeah, okay. I think we are together. I want to display item number 5. Item number 5. Yeah. Yes. Now here I am bringing the idea why it is important for you to summarize. Those who have looked at some mock papers, you might have found the numbers of that nature. So we must utilize our formulas very well. Allow me to start. Now, I want you always, let me know through the chat, what is going to be your X and what's going to be your Y.
Product A.
Yes? Let me know through the chat what's going to be your X and what's going to be your Y. Product A is my X, product B is my Y. Very good. People are asking me to zoom. Oh. The problem when I zoom, Okay, let me see what I can do. Let's hope. But I know you people can as well zoom from your side. But I know it is now a bit clear. Okay, now we are going to start, members. Now, like you have told me in the chat, that our product A is going to be our X and our product B is going to be our Y. Now, always summarize. It is a good practice to summarize. So here is going to be my A. I'm going to have my B. Now I will start. When you look at the company wants to maximize its profit, but there are several constraints related to production process. Each product requires different amounts of raw materials, labor, machine hours. Now I'm going to first start raw materials. Raw material. After raw material, I'm going to go on and say labor per unit. After that, I'm going to put machine hours. After that, I'm going to put the sales. That's and now I'm summarizing my table. Then I start for A. Here the raw materials are 2. These are 3 hours. This is 1 machine, and here is 50,000. I go to B. This is 3. This is 4. This is 2, and this is 70,000. Then I continue. Do I have the total? That yes. Raw materials, I have 500 kilograms. Labor, I have 600 hours. Then machine hours, I have 300 hours. Then this one, I don't have. Members, can I know whether I have summarized the way you are summarizing, whether that one is very okay? Chisache, thank you for that response. Yeah, people are saying the summary is very okay. Now, after you summarizing, what you have to do is to understand now which inequality sign to use. Then you start just going vertically like that. Now we go to the raw materials. The company has the following resources available. Raw material, 500 kilograms. Can you let me know through the chat which inequalities are we using? Which inequality are we using? We have 500 kilograms available. Which inequality are we using? Which inequality? Less than or equal to. Yes, yes, yes. Thank you, Mujuni. Thank you, Favor. Mugisa, yes. Less than or equal to. Very good. So I'm going to write my first inequality. All right. 2x plus 3y is less than or equal to 500. Yes, since that's what you have, it cannot go beyond that. So the second one, I'll go still, I say 3x plus 4y is less than or equal to 600. Good, good, good. Chemtai. Patricia.
Yes.
Yes, give us the third inequality.
Okay. X plus 2y is less than or equal to 300.
Okay, good. Mojoni, come back. Mojoni, come back. And unmute.
Yes, teacher.
Yes, give us the profit equation.
Say 50,000 times X plus 70,000 times Y.
Okay, good. Then, so this one is going to be our function that we shall use to maximize the profits. Okay, thank you so much. Then can write the non-negative that always our x will be greater than or equal to 0 and our y will always be greater than or equal to 0. Okay, thank you. Y is less than, okay. Yes, Amara, I don't know whether you have understood. Patricia has already responded. Amara?
Teacher, confused. So,
yes?
No, I'm just asking, why specifically did you use less than? Is it because that's the only option or resources they had given us in the question?
No, because here they have told us that the company has the following resources available. Raw materials, 500 kilograms. Just imagine at home, you have only 5 liters of water. So tell me, which inequality would you use? Less than or equal, greater than or equal, or less than or less than, or greater than?
Which I would use less than or equal to.
Yes.
But so that means, teacher, okay, what if the question was like, the company has only the following resources?
Yes, even if it has only the following resources, still we shall go with less than or equal to. Because the equal you want to bring in, that equal you want to bring in, it is being catered here when you say less than or equal to. So we cater it from there, the equal. Because less than or equal to means that something can either be equal to that or less than that.
Teacher, another question. What if they said has the following resources?
Has.
Not only not available, but has the following resources.
Yes. Now, it still depends on the question. If it is a maximizing question, still we shall use that less than or equal to.
Okay.
Yes. So always read the question, interpret, and then find out what does the question want. Are they maximizing? Are they minimizing?
Okay, teacher.
Okay. Calvin?
Sir. Excuse me, sir.
Yes, please.
Is it a condition that A has to be X and B has to be Y, or I can say product A to be Y and product B to be X?
Yes. Yes, like I said earlier on, it's not a must. You can interchange. However, many times when you are working out, or what they start with, it's always what they assume to be their X and Y. You'll get the same answers, but you may find challenges getting a graph that aligns well with what others have.
Okay, so it is advisable to
Yes.
product
Yes.
as X and X as Y. Okay,
yes.
So it is advisable to always
Yes, that's why I said, yes, that's why I said initially that always the first thing they start with, let it be your X, and then the second one, let it be your Y.
Okay, thank you.
Okay, yeah, and this is by the way one of the questions that you can go out of the exam when you know I have passed or I have failed. The moment you fail to bring out the inequalities, well, it may you'll still not be able to, you are not going to be able to do what? Now you'll not be in position to get the region. The moment you fail the inequalities, you cannot get the graph and you'll not be able to get the solution. So you go out of the paper knowing I've passed or have not passed. Okay, then kindly you're going to just take a screenshot of this number. You're going to try it in your free time. Yeah. 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 I'm only interested in you writing the inequalities. Please don't, there is no need for you to solve and draw the graph. I'm interested in you writing the what? The inequalities. So just take a screenshot. I am interested in part A. Now, those things we have been generating are what we call the mathematical statements. Those things we have been developing, when you meet those items, we call them mathematical statements. And I'm going to ask you now, since we have learned how to derive them, can you please now go on and look at those different past papers you have been seeing and check whether now you can be able to write the mathematical statements? So check out those papers you have and see whether if you meet this number, you can write those mathematical statements. Okay, I think members have finished. Members have finished. Okay, and I want to wish you a good day. Someone to lead us in a closing prayer. Who's leading us in a closing prayer? Okay, who has not said? Okay, Favor has never led us. Yes, Favor.
Let's humble ourselves and pray. Heavenly Father, we thank you for this day. We thank you for the gift of life. We thank you for you enabled us to wake up and attend this lesson, for many wished to, but they were not able. But we thank you for the grace you gave unto us to wake up, and we thank you for whatever we have learned, the linear inequalities. We thank you for everything, Father. And we thank you for our teacher. We thank you for the commitment and the love he has for us, O Lord Jesus. We pray that you will bless him, and we pray that you bless our day. Give us a great day, and we pray for the afternoon lesson, Father, that we shall understand, and we pray that whatever we have understood or whatever we have learned, that we shall use it in our integrations, in our end of term, in our UNEB, and that we shall pass highly. In Jesus' name we are prayed and believed. Amen.
Amen.
Thank you so much, Favor, for the word of prayer. Have a good day, everyone.
Have a
Thank you,
good day,
teacher.
teacher.
Bye.
Bye. Thank you, teacher.
Bye.
Bye-bye.